Hi everyone. So this is an computer in this computer networks lecture series. We will go with the continuation of the second routing algorithm, which is called as the link state routing. As we already know, it is also one of the intra-domain routing. That is, I am going to route the data packets inside the network. So here the algorithm what we are using is the Dijkstra's algorithm to build a routing table. Okay, so the topics here is that how to build a routing table, and then how to flood the data packets. So this is the initial table. Actually, each and every node will maintain a table, and then every router has a knowledge about the network from their own perspective. So here we will be disseminating a packet called as the LSP, that is called as the link state data packet. So each router floods this information, which is in the form of an LSP, to the out to the nodes periodically or when there is a change in the topology. So each router takes its data using the Dijkstra's algorithm and creates the shortest path tree. So Dijkstra's algorithm is one of the most famous algorithm used in the data structures to find out the shortest path to reach a particular node. So you can see that A state of link A is maintaining their neighboring nodes. So it is having 5, 2 and 3. So likewise in B's perspective, in E's perspective and C's perspective, it is maintaining one table. This packet will be passed to all the neighboring nodes when there is for every periodic table. So once the node is receiving this data packet, it will be comparing with the data values, whether the data inside this data LSP packet is old one or a new one. If there is an old one, means automatically it will discard it. If there is any change in the network, if there is any change in network, means it will use it. Okay, so that is given here. So here you can see this is the working workflow of the Dijkstra's algorithm. We'll start with that node. Set, you can take any node as a root node, and then same as it is just like what we have done in distance vector routing. You can take any node and try to find out the nodes which are unreachable. We start with the root node and then move to the tentative list. Tentative list means it is just for a temporary time, and then I'll be moving the tentative list to come to the permanent list. So before moving that, I'll try to find out the values. One second. Okay, so here you can see that I'll start with the A node as the root node, and then my neighbors are B, C and D. So I'll choose which node do I have to choose? I'll choose C as my node. Why? Because this is the shortest value, it is having the least cost. So I am finding out the A's value, and then I am moving from tentative list to permanent list. So A will be moving from initially A is also will be in the tentative list. Once I find out the value, and then it will be goes to the tentative list to permanent list. So you can see here. So afterwards, and then I am seeing C as my now my node is if the nodes which are there in the tentative list are B, C and D, right? So and then among these three nodes I will be choosing C as my next tentative node. Why? Because it is having the least cost. So before moving, I'll try to find out the neighbors which are there. I'll try to find out the neighbors which are there. So who are all the neighbors of C node R, and then E is there. So okay, so I'll try to find out the cost. In this way I am moving from before moving from tentative list to permanent list, I try to find out my neighbors and then the shortest distance among them. Thank you.